Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 8, subject chemistry, chapter number 1, revision, lecture number 17, and here is Mrs. Saira Jamal. Dear students, today I am going to talk about some more important topics of chapter number 1. The chemical calculations. I told you in my previous lecture that there are some important formulas which we have to use to solve all the numerical problems. Those important formulas are, the first one is number of atoms. If number of moles are given and number of atoms they ask about, then you have to use this formula. Number of atoms is equal to number of moles into Avogadro's number. This capital Na is for the Avogadro's number. Second formula, number of moles. If number of atoms are given and they ask about to find out the number of moles, then you have to use this formula. Number of moles is equal to number of atoms over Avogadro's number. If number of moles are given and the number of molecules you have to find, then this formula you have to use. Number of molecules is equal to number of moles into Avogadro's number. If suppose in a question grams or mass is given and they ask about the number of moles, then we have to use this formula. Number of moles equal to mass in grams over molar mass. If in any question number of moles are given and they ask about to find out the mass of that compound, then you have to use the formula mass of compound is equal to number of moles into molar mass. If in a question number of atoms or number of molecules are given and ask about to find out the mass of atoms or molecule, then you have to use the formula mass of atoms or molecules equal to number of atoms or molecules into molar mass divided by Avogadro's number. So dear students, these are the 6 important formulas to solve most of the examples and the numerical problems of the exercise. Let's do some of the important questions. Question number 15 of the exercise is calculate the mass of the following. Calculate the mass of the following. And what is given to us? Number of atoms are given. 3.24 into 10 raised to power 18 atoms of iron. It means that number of atoms are mentioned here and we have to find out the mass. So data. Number of atoms are given. Molar mass of iron 56. Mass of iron we have to find out. We will use the formula mass is equal to number of atoms into molar mass over Avogadro's number. By putting the values, number of atoms are 3.24 into 10 raised to power 18. Molar mass of iron is 56. This is 56. I mistakenly mentioned 54. 56. Avogadro's number is 6.022 into 10 raised to power 23. So 18 and this value will go up and become minus 23. So 18 minus 23 will give us the answer 30.1 into 10 raised to power minus 5 grams. By shifting the decimal, this decimal by shifting it, we will get the answer 3.01 into 10 raised to power minus 4 grams. B part of the same question number 15, calculate the mass of 2 into 10 raised to power minus 19 molecules of nitrogen gas. In this case, molecules are given. In the previous question, number of atoms were given, and in this case, number of molecules are given. Although the method, the formula is same, only the difference is in the molar mass. Molar mass of nitrogen is different. Like nitrogen exists in diatomic form, so we will use N2, and the molar mass of one nitrogen atom we multiply with 2. Why we multiply it with 2? Because there are two atoms of nitrogen. So it will give us 28 grams. Number of molecules are given. Molar mass of nitrogen molecule is 28 grams. Mass of nitrogen gas we have to find out. Avogadro's number, I told you, you have to learn it. And now by using the formula of mass in grams is equal to, in this time we will use number of molecules. In the previous slide, we used number of atoms. So number of molecules into molar mass over Avogadro's number. Now by putting the values, number of molecules are 2 into 10 raised to power 19 into molar mass of nitrogen 28. Avogadro's number of nitrogen is 6.022 into 10 raised to power 23. Again, I told when this 23 will go up, it become minus 23. The answer is 9.3 into 10 raised to power minus 4 grams. Think tank, important question. Question number 6. Calculate the total number of atoms present in 18 grams of water. We have to find out total number of atoms. In how much water? 18 grams of water. What is given to us? Mass is given to us. So we will use mass of water equal to 18 grams. We have to find out the number of atoms. Molar mass of water, 2 is atomic mass of hydrogen. 2 are the number of atoms of hydrogen, and 1 is the atomic mass of hydrogen, plus 16 is atomic mass of oxygen. So 2 1 are 2, 2 plus 16 equal to 18 grams. By using the formula number of moles, because first we have to find out the number of moles. To find out the number of atoms or to find out the number of molecules, first we need the number of moles. So the first step is to find out the number of moles. Number of moles is equal to mass in grams over molar mass. So first we will find out the number of moles. 18 grams is the mass of given mass of water, and 18 gram is the molar mass of water as well. So 18 over 18 will give us answer 1 mole. Now moles, we found the moles. Now number of molecules is equal to number of moles into Avogadro's number. Now we will use that number of moles in this formula. Number of moles into Avogadro's number, it will give us the answer, the same answer, because 1 mole multiplied by Avogadro's number will give us the same answer. So it means that 18 grams of water contain how many molecules? Avogadro's numbers of molecules. Now this is molecule, but we have to find out the number of atoms. Now let us see, 1 molecule of water has 2 hydrogen atoms and 1 oxygen atom. Therefore, total number of atoms in 1 water molecules are 3. If 1 water molecule contains 3 atoms, then how many atoms will be present in these Avogadro's numbers of molecules? 1 water molecule contains 3 atoms, then Avogadro's numbers of molecules of water will contain how many atoms? So 1 water molecule has 3 atoms. Avogadro's number of molecules will have 3 into Avogadro's numbers of atoms. They are 1.806 into 10 raised to power 24 atoms. So to find out the total number of atoms, if mass is given, we have to first find out the number of moles. Then from the number of moles, we have to find out the number of molecules. And then from the number of molecules, you have to find out the number of atoms. So there are 3 steps of this question. First one to find out the number of mole, second one to find out the number of molecules, and the last step is to find out the number of atoms. Question number 3 of think tank is also a very important question, that is to find out the mass of 1 hydrogen atom in gram. We have to find out the mass of 1 hydrogen atom. Again, number of atoms are given. That is one atom. And we have to find out the mass, same like the previous question. So number of atoms given are only one atom. Mass of one hydrogen atom in grams we have to find out. Molar mass of hydrogen is 1 gram. And for solution we will use the formula of mass. Mass of one hydrogen atom is equal to number of atoms into molar mass over Avogadro's number, the same formula. By putting the values, number of atoms are it is only one atom. Molar mass is 1. Avogadro's numbers Avogadro number is 6.022 into 10 raised to power 23. By dividing we will get the answer 0.1674 into 10 raised to power minus 23, or by shifting the decimal we will have 1.674 into 10 raised to power minus 24 grams. So by using the formula of mass in question number 3, also in question number 6, we can find out the mass of one atom or whatever the number of atoms are. Now coming towards example 1.5. Example 1.5 is calculate the mass of a given number of moles of a substance. Now in this numerical problem, number of moles will be given and we have to find out the mass. So the first question is oxygen is converted to ozone. Oxygen is O2 molecule and ozone is O3 molecule. Both are the allotropic forms of each other. During thunderstorms, calculate the mass of ozone if 9.05 moles of ozone is formed in a storm. Number of moles given are 9.05 and we have to find out the mass. So data is number of moles given are 9.05 moles. Mass of ozone we have to find out. Molar mass of ozone, there are 3 atoms of oxygen. Mass of an oxygen atom is 16 multiplied by 3 will give us the answer 48 grams. So 48 grams are the is the molar mass of ozone. We will use the formula mass of ozone is equal to number of moles into molar mass. Mass of ozone, number of moles into molar mass. I told you when number of moles are given and they ask about the mass, then you have to use this formula. And in the previous case, when number of atoms or molecules are given and you have to find out the mass, then you use the formula that is mass is equal to number of atoms or molecules into molar mass over Avogadro's number. But if number of moles are given and they ask about to find out the mass, then we will use this simple formula. Mass of ozone or mass of whatever atom or molecule equal to number of moles into molar mass. By putting the values, number of moles are 9.05. Molar mass of ozone we have found here, that is 48. So the answer is 434.4 grams. Example 1.6. When natural gas burns methane, carbon dioxide is formed. If 0.25 moles of carbon dioxide is formed, what mass of carbon dioxide is produced? Again, the same thing. Number of moles are given and we have to find out the mass. So number of moles of carbon dioxide 0.25 moles. Mass of carbon dioxide we have to find out. Molar mass of carbon dioxide, atomic mass of carbon is 12. There are 2 oxygen atoms and atomic mass of one oxygen atom is 16. So 16 into 2 will give us 32. 32 plus 12 is 44 grams per mole is the molar mass of carbon dioxide. We have to find out the mass of carbon dioxide. Formula we will use equal to number of moles into molar mass. So number of moles are 0.25 moles and molar mass of carbon dioxide is 44 grams. The answer is 11 grams of carbon dioxide will form. Example 1.7, converting grams into moles. In the previous case, we convert moles into grams. Moles were given, and we found the um, grams. Yeah, moles were given, and we have to find out the grams. In this case, grams will be given, and we have to find out the number of moles. Let us see in the first equation how many moles of each of the following substances are present. A balloon filled with 5 grams of hydrogen gas. Now mass is given and we have to find out the moles. The given data is, given mass of hydrogen gas is 5 grams. Number of moles of hydrogen gas we have to find out. Molar mass of hydrogen gas 2 into 1.08, 1.008, which is the atomic mass of one hydrogen atom. By multiplying, we will get 2.016 grams. Dear student, in some numericals we just put 1, and in some numericals we put 1.008. So no matter if you will use 1 or if you will use 1.008, the answer, the difference will be only in fraction. Like if you use only 1, then the answer will be 2. But as we in this case use 1.008, so the answer is 2.016. This value is only different. That will show very little effect on the answer, but both methods are correct. Okay, don't get confused in this case. Solution will use the formula of number of moles equal to mass in grams over molar mass, mass in grams over molar mass. By putting the values, mass given is 5 gram, molar mass we just found it over here is 2.016. So the answer is 2.48 moles of hydrogen. Then we have B part of the same question. A block of ice. Ice. What is ice? Ice is water, the solid form of water that weighs 100 gram. So the data given is given mass of water 100 gram, number of moles of water in the ice. We have to find out molar mass of water. Again, it is 2 plus 16, which is atomic mass of oxygen. So 18.016. Number of moles of water, we use the formula mass in grams over molar mass. Mass, given mass is 100, molar mass of water is 18.016. The answer is 5.55 moles of water or ice. Example 1.9, calculating the number of molecules in given moles of a substance. Now in this case, if moles are given and we have to find out the number of molecules. Methane is a major component of natural gas. How many molecules are present in 0.5 moles of a pure sample of methane? It's very easy. Data given is moles of methane are 0.5 moles. Number of molecules we have to find out. Avogadro's number are 6.022 into 10 raised to power 23. And we will use simple formula. Number of molecules equal to number of moles into Avogadro's number. 0.5 into 6.022 into 10 raised to power 23. It will give us the answer 3.011 into 10 power 23 molecules. Next we have a second part. At high temperature, hydrogen sulfide gas given off by volcano is oxidized by air to sulfur dioxide. H2S react with oxygen which is present in the air. This is called oxidation. Addition of oxygen by sulfur to form sulfur dioxide. Sulfur dioxide react with water and form sulfuric acid. Sulfuric acid make the rain acidic rain because sulfuric acid is a strong acid. It when mixed with the rainwater will make the rainwater acidic. How many molecules are there in 0.25 moles of sulfur dioxide? We have to find out the molecules. Moles are given. The same formula which we use in the part 1. Moles of hydrogen sulfide given are 0.25 moles. Number of molecules we have to find out. Avogadro's number we have to learn 6.022 into 10 raised to power 23. Formula I told you is number of molecules is equal to number of moles into Avogadro's number. By putting the values 0.25 into 6.022 into 10 raised to power 23, answer is 1.50555 into 10 raised to power 23 molecules. Example 1.10, calculating number of moles in the given number of atoms. Atoms are given, we have to find out the moles. Reverse of the previous question. In that case, moles were given and asked about the number of atoms and molecules. And in this case, they ask about the number of atoms or molecules. Moles are given. Titanium is corrosion resistant metal. Corrosion resistant metal, it means that it does not corrode and it is resistant towards reaction with oxygen and moisture in water. So that is used in rockets, aircrafts, and jet engines. Calculate the number of moles of this metal in a sample containing 3.011 into 10 raised to power 23 titanium atoms. Number of atoms are given and we have to find out the number of moles. Number of molecules or number of atoms given are 3.011 into 10 raised to power 23. Avogadro's number, you have to learn formula which we have to use. Number of molecule is equal to number of moles into Avogadro's number, but we have to find out number of moles. By taking out the number of moles is equal to number of molecules over Avogadro's number. By putting the values 3.011 into 10 raised to power 23 over 6.022 into 10 raised to power 23 will give us the answer. 0.5 moles of titanium atoms are present. Self-assessment exercise 1.5, that is about the question. Explain why an oxide ion has -2 charge. Oxide ion means oxygen atom has -2 charge. Why an oxygen atom has -2 charge? When it is converted into the ion form, it is called oxide. And you can see neutral oxygen atom, and after gaining 2 electrons it become an ion. Gaining of ion, or when an atom gain an electron, it will convert it into an ion which is called anion. So oxygen from atomic form is converted into ion. Oxygen into oxide, that ion is called oxide ion. So why an oxide ion has -2 charge? Why you can see -2 charge this oxide ion has. So oxygen has a nucleus of 8 protons. 8 protons are present in the nucleus because atomic number of oxygen is 8. So it means that it has 8 protons in the nucleus, and mass number is 16. So it has 8 neutrons in it. So 8 plus 8, 16. Thus, its nucleus has a total charge of +8. Why it has +8? Because neutrons are neutral. Neutrons have no charge. So the charge on nucleus is only due to the presence of the positive particles, and those positive particles are protons. So nucleus has a total charge of +8. Around the nucleus, as atomic number is 8, so I told you number of protons and number of electrons are always same. So around the nucleus in the ion are 10 electrons, and the total charge will be -10 for the 10 electron. The charge on the ion will be, there are +8 charge due to the 8 protons, plus -10 charge due to the 10 electrons, because oxygen after gaining 2 electrons, before gaining electron in neutral oxygen atom, atomic number of oxygen is 8. So you can see 2 electrons are present in the first shell and 6 electrons are present in the second shell. So to complete this second shell, oxygen needs 2 more electrons to have 8 electrons in this outermost shell. Because there is a rule called octet rule which states that an atom becomes stable only when its outermost shell is completely filled with have 8 electrons in it. So oxygen, in order to become stable or in order to gain stability, it will gain 2 electrons. So after gaining 2 electrons, it will convert it into -2, means it gains 2 electrons, and you can see it have now 8 electrons in the outermost shell. In this case, in neutral form, 6 electrons in the outermost shell, and in the ion form, it has 8 electrons in the outermost shell. So +8 for the protons and -10 for the electrons. +8 plus -10 will give us the answer -2. That's why an oxide ion has -2 charge. Second example is for magnesium ion has +2 charge. Why magnesium ion has +2 charge? Magnesium has a nucleus of 12 protons because atomic number of magnesium is 12, mass number is 24, so it has 12 protons and 20 neutrons, and its nucleus have a charge of +12 because I told you neutrons have no charge. Then around the nucleus in the shell there are, in the ionic form there are 10 electrons. You can see as magnesium has atomic number 12, so it has 2 electrons in the first shell and 8 electrons in the second shell and only 2 electrons in the last shell. According to the octet rule, which I told you, it states that an atom becomes stable if it has 8 electrons in the outermost shell. So it has only 2 electrons. So how can it take 6 more electrons? That is not possible because a very large amount of energy is required to lose these two, or to gain 6 electrons. The only easiest way is that this metal will lose their 2 electron and will have this second shell will be the outermost shell now, and it has 8 electrons, so the outermost shell will be completed. So the magnesium will convert it from neutral magnesium atom to Mg+2 ion after losing 2 electrons. Okay, so instead of 12, as it loses 2 electrons, so I have 10 electrons now with a total charge of -10. Charge on the ion will be protons are 12, so +12, and electrons are 10 because 2 electrons magnesium loses. So net charge is +2. The last example is of the sulfide ion. Why the sulfide ion has -2 charge? Why it has -2 charge? Sulfide comes from sulfur. Atomic number of sulfur is 16 and mass number is 32. It has 16 protons. 32 is the mass number and 16 is atomic number. So 16 protons and electrons are always same. 16 protons and 16 electrons. And 16 plus 16 will give us 32. So neutrons are 32. Charge on the nucleus will be 16 because there are 16 protons and 2 electrons are present in the first shell, 8 electrons are present in the second shell, and 6 electrons are present in the last shell. So in order to complete 8 electrons or to have 8 electrons in the outermost shell, it has to gain 2 electrons. So like oxygen, sulfur will also gain 2 electrons and then will form sulfide ion. You can see S-2 sulfide ion. Electronic arrangement: 2 electrons in the first shell, 8 electrons in the second, and 6 in the last shell. It is incomplete shell. So to complete this shell, it will gain 2 electrons, and you can see it is now complete shell or full shell. Sulfur has a nucleus of 16 protons and 16 neutrons, thus its nucleus has a total charge of +16. Around the nucleus in the ion there are 18 electrons with a total charge of -18. So the charge on the ion is +16 because there are 16 protons and electrons are 18. So -18, 16 plus -18 will give us the answer -2, which shows that it has only the 2 charge on it. So sulfur from neutral form, it is converted into the sulfide form, that is -2. And I told you that when an atom gain electron, it's converted into negatively charged ion. And when an atom loses electrons, it is then converted into positively charged ion. Negatively charged ions are called anion, and the positively charged ions are called the cation. So they will form the cation. So hope you will understand this lecture, learn this chapter and also the second chapter thoroughly. Inshallah, we'll meet you in the next lecture. Thank you. Take care. Allah.